Hello, today I am going to discuss about the relationship between the VFD output frequency and the agitator speed. When we talk about speed, we have to understand, are we talking about the motor speed only, or are we talking about the agitator speed or other speeds such as pump speed, crane speed, conveyor speed, etc. In today's discussion, we are talking about the VFD output frequency, motor speed, as well as the agitator speed. Okay, so the speed is can be in terms of revolution per minute or RPM, can be in terms of frequency or hertz unit. So basically, when we talk about the frequency, is this closely associated to revolution per minute, which is refer to the same thing as speed here. So let me draw a simple picture so that we can understand further for today's discussion. Okay, let's say I have a three-phase power supply, L1, L2, and L3. And then this three-phase power supply will go through a isolator. Note that this is just a simple diagram for illustration purpose. The actual design will be much more complicated than this one. And then this three-phase power supply will go through the VFD, variable frequency drive. And then VFD will supply the output power with variable frequency to the motor. Alright, okay. And then this motor will drive a gearbox. Alright, and then this gearbox will drive the agitator inside a tank. Okay, this is a tank filled up with water. So this agitator basically is just a blade. Okay, so that the blade will spin to stir or to agitate the fluid inside the tank so that it will be evenly distributed and mixed around. Okay, so this is an agitator. Alright, this is a VFD. Sometimes people call it VSD, variable frequency drive, variable speed drive. It basically refers to the same thing. Okay, this is a three-phase motor, and then this is a gearbox. Gearbox is basically a device to reduce the motor speed. Okay, it has the reduction ratio. Okay, reduction ratio, maybe it can be 7 to 1, 6 to 1, 8 to 1, etc. So basically it just reduces speed. Okay, this is a agitator. So when we talk about speed, okay, this speed can be referred to as the frequency, also can be referred to as a revolution per minute. Frequency, the unit is hertz. Revolution per minute, the unit is RPM. Okay, so this VFD will do the controlling and then produce a corresponding power with a variable frequency. Okay, and this frequency with this power with different frequency will be supplied to the motor, and the motor speed will change. Okay, so once the motor speed change, and this motor speed will be reduced by the gearbox, and thus this gearbox with the reduced speed will drive the agitator to agitate the fluid inside the tank. So when we talk about speed, we have to understand whether we are using the frequency or we using the revolution per minute to refer to the speed. In this Excel sheet, which was created by me to calculate the corresponding uh, motor speed and the agitator speed. Okay, so if you are interested to get this Excel sheet, please leave a comment and I will send this Excel sheet to you. Okay, we have to fill out all the value inside the yellow boxes. Okay, so we for this output percentage column, okay, I fill out the value 0% as my minimum output percentage and 100% as my maximum output percentage. Usually the percentage is from 0% to 100%. This is a quite standard practice. As for this VFD output frequency, the unit is hertz. Refer to this VFD output frequency. The range is 0 Hz minimum range and the maximum range is 50 Hz. As for the motor speed, in terms of RPM unit, I use 0 RPM as my minimum range and then the 2700 as my maximum RP motor speed range. Of course, I can change any value that I want. Okay, I can change this to 1000, 2000, 3000, 5000, etc. You just need to key and change the value and enter it. Alright, and then it will automatically calculate the corresponding agitator speed. As I said before, the agitator speed also it depends on the reduction ratio of this gearbox. So this gearbox reduction ratio is 8. So basically it will divide the value of the motor speed by 8. Then you will get the agitator speed here. Okay, sometimes we may need to use a different minimum frequency. Okay, some process require minimum frequency. That is to say, when the speed is set as 0%, the agitator will still turning because there is a minimum frequency. Such as in this case, the minimum frequency that I set here is 10 Hz. The agitator will spin or agitator at 10 Hz minimum frequency, even though the motor speed is set at 0%. This is due to the process requirement. Okay, it depends on the process requirement. If the process requirement require certain minimum frequency, then you have to set the minimum frequency, such as in this case. If the process do not need any minimum frequency requirement, then you do not need to set the minimum frequency. Okay, in this case, I modify my minimum frequency as 10 Hz. The maximum VFD frequency remain at 50 Hz. So it will automatically calculate the modified motor speed here and the modified agitator speed. Okay, how to get this value is simple. So as we know, speed is related to the Hertz and the RPM, right? So 0 Hertz is correspond to 0 RPM and 50 Hertz is corresponds to 2700 RPM. So if the minimum frequency is 10 Hertz, so you will get about 540 RPM. How we get this is very simple. As we know, 50 minus 0 is proportional to 2700 RPM minus minimum RPM. Alright, so if we set the 10 Hz modified frequency, what you will get is about 10 divided by 50 multiplied by 2700, then you will get about 540 RPM. this 540 RPM is this value, which is correspondent to 10 Hertz here. Okay, for this percentage 0, 25, 50, 75%, 100%, you will get the corresponding VFD output frequency from 0 to 12.5 to 50 Hz as shown here, and then its corresponding motor speed in terms of revolution per minute 0, 675, 1350, and then to 2700 RPM. Okay, so you will get the agitator corresponding agitator speed as shown here. So this all value is for the VFD output frequency of 50 to 0 to 50 Hz. If we modify the VFD output frequency from 10 Hz to 50 Hz instead of 0 to 50 Hz due to the minimum frequency requirement as per system owner or the process requirement. So the corresponding modified VFD output frequency is shown here. So the 0% is no more correspond to 0 Hz. 0% produce corresponding 540 RPM, which is a modified motor speed, and the corresponding modified agitator speed will be 67.50 revolution per minute. Similarly, for the 50%, it will not correspond to 25 Hz or 1350 RPM motor speed or 168.75 RPM of agitator speed. Instead, for the 50%, it will correspond to 30 Hz or modified VFD output frequency, which is this one, and then it will correspond to 1620 modified motor speed, which is this one, and then it will generate 202.50 RPM modified agitator speed, which is this one. Okay, so that's it. Thanks.